So what we're going to be doing today is how to write a polynomial from roots. This will also help you if you've been struggling with when you get the zeros going back and writing the factor. I know for some of you that's been, is it plus, is it minus? How do I get it into those parentheses? So this hopefully will shed a little light on that too. So on the entry task today, we took the entry task and wrote the factorization. So just to get this in the notes, this is linear factorization form. So when it asks you for a linear factorization, it means that you're going to be using x to the power of 1 for all of your factors. I'm not going to write all of these from the entry task, but linear means these are all x to the power of 1. And then, of course, we had a leading coefficient. So if you are on your homework looking at a graph and they expect you to find all the solutions, there's just a couple things that might help you do that a little bit easier. So all solutions or zeros. So if you're actually looking at a graph, it means that all of the zeros that you're looking at are going to be real zeros. If they were imaginary, you can't tell that from the graph. They won't even show up. So you have to assume all the zeros that you're expected to find are real. You also can assume, just because it's impossible for you to tell the difference between 2.1 and 2.2. There's no way in heck. So you can assume that all the zeros that they're going to want you to get are rational, which means no square root anything, just regular numbers. And then the other assumption that you can make is if the 0 is in between numbers, you can go by 0.5s. But that's it. No, don't go by 0.2s or 0.3s. There's no way you can tell that. So just assume if it's in between a 1 and a 2, it's a 1.5. Okay, so that hopefully makes that a little bit easier. Okay, Roman numeral 1, conjugate pairs. And we've learned a little bit about this before, but it's never played as large of a role as it is today. So basically, conjugate pairs means there are always 2 of them. And typically there's a plus and a minus difference between each of the pairs. So for example, you can have conjugate pairs where there's a radical in them. In other words, the number is irrational because it's trapped in the radical. So if you get a plus square root b as one of your zeros, automatically 100% of the time, a minus radical b will be the other 0, and you just know that. So if you get 1, you get 2. The other conjugate pair are complex conjugate pairs, which means they have I in them. If you get a root or a 0 that is a plus bi form, automatically there's an a minus bi form. Now on both of these, just take extra special notice. It's the middle sign that changes. The a is still positive, or if a is negative, they're both negative. Same thing here. A's don't change, just the middle sign changes. And that's why the quadratic formula has plus and minus a square root. It's acknowledging the fact that if it has a square root, it always comes with a plus and a minus. You just didn't know that at the time. Okay, so let's do an example. Let's say that you're given the roots to a function, x equals 4, 5i, and negative radical 6, and you're supposed to find the remaining roots. And sometimes they'll tell you the degree, but honestly, it doesn't matter if they tell you or not, because there's only one degree possible. So they might say it's a degree 5, and they might not tell you anything. They might just say, find the remaining roots. Okay, so x equals 4 is a whole number. That's it. Those come singly. So because there's a 5i, that means there has to be a negative 5i root. because there's a negative radical 6, there has to be a positive radical 6 root. So actually there ends up being 5 roots. It is a degree 5 with the conjugate pairs. So that's how you do those questions. Pretty straightforward. Okay, Roman numeral 2. Leading coefficient change. Leading coefficient change. Okay, so f of x equals x cubed plus 2x minus 1. And they want you to change the leading coefficient to a negative 4. Okay, so they want you to change the leading coefficient, but they're not going to change the zeros, just the leading coefficient and nothing else. So the way you do this in polynomial form, which is the one you're looking at, that's polynomial form, is you take the entire function and multiply it by a negative 4, the whole function. The reason it has to be the whole function is that if you just multiply by the first number, you've changed the zeros. And we don't want to change the zeros, we just want to change the leading coefficient. So your answer on this one would be negative 4x cubed minus 8x plus 4. And this would not change the roots because when you factor it, that negative 4 would divide to the front, and then what's left would be factored. So it would not change the actual factors. Okay, so this is a slightly different technique than if it's in factored form. Let's say g of x equals x plus 1 times x minus 3, and they want you to change the leading coefficient to a 5 without changing anything else. When it's in factored form, it's even easier to change the leading coefficient because these are all multiplied together. So you can just put a 5 at the front as a scalar. And since 5 is being multiplied by everything, you're accomplishing the same thing we did in the first example. You're just not multiplying it through. Just let it park out front. So this is in polynomial form, this is in factored form. All right, questions about leading coefficient changes? And you don't want to put an x out there because you don't want to change the zeros, you just want to change the leading coefficient. If you put an x with the 5, now you've added x equals 0 as an additional solution, and you don't want to do that. Okay, Roman numeral 3. Writing polynomials. At the end of notes, you can put your cell phone on my desk. Okay, so let's say that you have zeros, and they might use roster, they might not. 3 minus radical 7 and 2i. And your mission is to write the polynomial that has those roots. Okay, so using the new stuff that we just learned, you know that both of these come in a conjugate pair. So 3 plus radical 7 is another 0, and negative 2i is a fourth 0. So we're looking for a degree 4. Okay, so the way you actually write this is you take each of these. We'll just start with the 3 minus radical 7. So you're going to write an x minus, and then in parentheses, 3 minus radical 7, close, close. That's how you turn a 0 back into a factor. You subtract it, and you put it in parentheses. Okay, so we're going to do the same thing with its conjugate pair. So x minus, in its own parentheses, 3 plus radical 7. Okay, and then now the 2i. And in this one, because it's a positive 2i, you don't have to use parentheses, but I've been told that's confusing. So we're just going to put the 2i in parentheses. That should be an x, sorry, not a 2. And then x minus negative 2i. Okay, so all we did was put x minus and then whatever the 0 is in parentheses. Now we're going to distribute the negative. So x minus 3 plus radical 7, x minus 3 minus radical 7, x minus 2i, x plus 2i. Now, if they're looking for the linear factorization with those zeros, you're done. That's it. So this is your linear factorization form. All right, if they ask you to write it in polynomial form, this is a whole different ball of wax. This you have to multiply out. Okay, so there are easier and harder ways to multiply out. One of the easier ways to do it is to multiply, multiply the conjugate pairs first, and then multiply what you get together, because a lot of terms drop out when you multiply a conjugate pair. So we're going to multiply the first pair. So x minus 3 plus radical 7, x minus 3 minus radical 7. We're just going to multiply that pair together. You can do it using columns or rows. I don't typically do columns when it's this many different kinds of terms. I just do it in rows, but that's up to you. So starting with x, we're going to distribute. X times x is x squared. X times negative 3 is negative 3x. X times negative radical 7 is negative radical 7x. Now the negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Negative 3 times negative radical 7 is positive 3 radical 7. All right, now we're going to distribute the radical 7. Radical 7 times x is radical 7x. Radical 7 times negative 3 is negative 3 radical 7. And positive radical 7 times negative radical 7, well, a positive times a negative is a negative. 2 7s, 1 comes out, so negative 7. Okay, so now you want to carefully cross off things that add up to 0. So negative radical 7x and positive radical 7x add up to 0. 3 radical 7 and negative 3 radical 7 add up to 0. So now I've got some things I can add together. I only have one x squared. Negative 3 is negative 6x. 9 minus 7 is a 2. So all that weird factorization is a simple trinomial. Okay, so we've multiplied the first two. Now I'm going to multiply the 2i factors. So we're going to multiply x plus 2i and x minus 2i. Again, I'm going to use rows, just personal preference. So x times x is x squared. X times negative 2i is negative 2xi. I always comes last. Now go to the next term. 2i times x is positive 2xi. And then 2i times negative 2i is negative 4i squared. If you remember, I squared equals a negative 1. So that 4 is going to be multiplied by a negative 1. And we're going to replace the I squared. You never, ever, ever have an I squared in an answer. Okay, so cross off anything that adds up to 0. 2xi minus 2xi. And I'm left with x squared plus 4, because negative times a negative is a positive 4. All right, we're on the last step. So now we're going to take x squared minus 6x plus 2 and multiply it by x squared plus 4. So here we go. X squared times x squared is x to the 4th. x squared times 4 is positive 4x squared. Go to the next term. Negative 6x times x squared is negative 6x cubed. Negative 6x times positive 4 is negative 24x. Go to the third term. 2 times x squared is 2x squared. 2 times 4, 2 plus times 4, excuse me, is 8. So 2, 2, and 2. Okay, what I usually do is I look ahead and go, is there anything I'm going to add together? I think the only thing that's got a duplicate is the x squared term. Everything else is singular. So I'm going to start putting it into polynomial order. So highest power first, so x to the 4th. And then minus 6x cubed. And then 4 plus 2 is 6x squared. And then minus 24x and plus 8. And that is polynomial form. So it's a whole lot of multiplying, but if you can take it in pairs and do the conjugate pair and the conjugate pair, get those answers and then put them together and multiply, it goes a lot faster. All right.